x plus a is equal to 0, a not equal to 0. Solve the equations means you have to find out the value of x. If this determinant value equal to 0, for what value of x this determinant value equal to 0? That is we are going to find out. We are going to find out the value of x. So first of all, simplify this. I am going to apply that, and I'm going to apply that my C1 as column 1 as C1 as C1 plus C2 plus C3. Why, sir? So suppose if you apply C1 plus C2 plus C3, x plus a plus x, this is 3x plus a. So therefore, I am going to apply that C1 plus C2 plus C3. That is my C1. Adding all these three and write it here. Adding all these three and write it here. So therefore, this is also 3x plus a. This is also 3x plus a. Okay, the second row, second column is x plus a, x plus a equal to 0. This is given. Equal to 0 is given. I am applying this column operation. Right. Now 3x plus a is common. Take it outside. When you take it as 3x plus a commonly outside, here I am getting 1, 1, 1. Here x plus a, x, here x plus a equal to 0. Okay. So now this is 3x plus a. So I have already told that if you are getting 1, 1, 1, we can make it as 1, 0, 0. How to apply that? So apply my R2 as R2 minus R1. Apply this row operation. My R3 as R3 minus R1. Apply these two row operation and make it this portion is 0, this portion is 0. Right? So therefore this is 1x. When you apply R2 minus R1, this is 0. When you apply x plus a minus x, this is a. When you apply x minus x, R2 minus R1, this is 0. R3 minus R1, this is 0. 1 minus 1, 0. X minus x, 0. X plus a minus x, that is a. Okay, equal to 0. Right? Now find the value of the determinant. That is 3x plus a. Expand the determinant. This is 3x plus a. What is the expansion? This is 1 into. Okay, so this is a square minus 0. So therefore, a square minus 0. I am going to expanding the determinant by the first column, plus minus plus. The second term is 0, third term is 0. No need to write the second and third term, only the first term. Your first term is nothing but 1 into a square minus 0. This is equal to 0 is given. So therefore, your 3x plus a into a square equal to 0. But look at that, in your problem, your a is not equal to 0. This is not equal to 0. But multiplying these two, it is equal to 0 means this is definitely 0. Okay, so therefore your x is equal to minus a by 3 is the value. Okay, where x is equal to minus a by 3. Okay, so now come to that. The 11th problem. Look at the 11th problem in our exercise. Alpha, beta, gamma. Alpha square, beta square, gamma square. Here beta plus gamma, sorry, beta plus gamma, gamma plus alpha, and alpha plus beta equal to beta minus gamma, gamma minus alpha, alpha minus beta into alpha plus beta plus gamma. Okay, so my LHS is, so look at that, here beta plus gamma is there, here gamma plus alpha, here alpha plus beta is there. But here in these two first row, the first two elements having some alpha, but here there is no alpha. Here beta is there, but here there is no beta. Here gamma is there, here there is no gamma. So if the any one row having any one common element alpha or beta or gamma, we can take it outside, but it is not like that. Alpha is not common in all the terms in the first row. Similarly in the second row, similarly in the third row, nothing is common. Then what to do, sir? Right? I'm going to apply some other row operation or column operation. If you add all these three, what happens? Alpha plus alpha square plus beta plus gamma. If you add all these three, beta plus beta square plus gamma plus alpha. Okay, but here look at that. When I'm adding these three elements, I'm getting 3x plus a. When I'm adding these three elements, I'm getting 3x plus a. When I'm adding these three, I'm getting 3x plus a. 3x plus a is common. Take it outside. But here it is not like that. When you add this is, I'm getting one value. When I add this is, I'm getting different value. When I'm adding these three, I'm getting different value. Similarly, if you add these three, alpha plus beta plus gamma. If you add these three, alpha square plus beta square plus gamma square, different element. If you add these three, you are getting different element. So therefore, that logic is not applicable here. That row operation and column operation never help us in this problem. Okay, then what to do, sir? I'm going to add these two, column 1 and column 2. Here beta gamma is there, alpha is missing. Add this alpha. Here gamma alpha is there, beta is missing. Add this beta here. Here alpha plus beta is there, gamma is missing. Add this gamma here. So therefore, my third column is, there is no change in the first column, no change in the second column. Okay, but I'm going to add my third column is column 3 is column 3 plus column 1. So therefore, I will get alpha plus beta plus gamma. Here also alpha plus beta plus gamma. Here also alpha plus beta plus gamma. Okay. I am writing my third column is third column plus first column. Because this alpha plus beta plus gamma is the part of the answer. Look at the right hand side. The part of the answer is alpha plus beta plus gamma. Here I am getting alpha plus beta plus gamma in all the three elements in the third column. Take it outside this alpha plus beta plus gamma. Alpha plus beta plus gamma. Okay, so that is here alpha, beta, gamma. Here alpha square, beta square, gamma square. Here 1, 1, 1. Okay, so therefore this is alpha plus beta plus gamma. Right, now if you are getting 1, 1, 1, then I have already told that if you are getting any one row or one column as 1, 1, 1, we can easily apply that R2 minus R1 or C2 minus C1 logic and make it 1, 0, 0 and expand the determinant, you will get the answer. Right, I'm going to apply that R2 minus R1. Here it is alpha, alpha square, here it is 1. Now I'm going to apply the R2 minus R1. That means this minus this 0. I'm going to make it this is 1, 0, 0. So this minus this. So that is beta square minus alpha square. This is beta minus alpha. Okay, and similarly this is 1 minus 1, 0. And this is gamma square minus alpha square. Okay, and this is gamma minus alpha. Okay, so therefore now I'm going to apply that. I have already told that if any term is coming like that, so dear students, some student asking question in board exam how much. So look at that, your chapter 1 and 2, you have only 8 marks. Chapter 1 and 2, 1 is relation and function, 2 is trigonometry functions, totally 8 marks only. Okay, chapter 3 and 4, that is matrices and determinant, this chapter. 4 is this chapter, totally 10 marks only. In this 10 mark, 1 6 mark confirm. In this 10 mark, 1 6 mark they are asking, particularly in determinant they are asking. They may be asked in matrices also. Okay, in matrices we have only the big question is finding A inverse using elementary operation, right? So they may be asked this question, or in matrices they may be asked 1 6 mark. Okay, and chapter 5, 6, 7, 8, 9. These 5 chapters are called as calculus. That is integral calculus and differential calculus. Okay, from these 5 chapters, we have 35 marks out of 80. I am telling about the mark percentage, marks picked up for 80 marks only, because you have 20 internal marks. This is the old pattern, 2019-20 pattern. But I don't know about the 2021. This year, they may be reduce some syllabus, they may be change the pattern. Okay, I don't know, but I'm telling about the previous year. This is calculus 35 marks. Okay, and the chapter 10 and 11. Okay, this is vector and 3D. We have 14 marks. Okay, and the chapter 12, that is linear programming problem. We have 5 marks only. Okay, and in 13, the probability chapter, I think we have 8 marks only. Okay, so I don't know the exactly the probability. It may be 9 marks or 8 marks, or otherwise this may be 16 marks. Not 14 means this may be 16 marks. Okay, so in your chapter, this chapter, I will give the confirmed marks tomorrow. In this chapter, this is confirmed. This chapter, we have only 10 marks, 3 and 4. Not only this chapter, matrices and determinants, we have 10 marks. Okay, right, now come to the problem. This is apply a square minus b square formula. Any other doubt? Apply a square minus b square formula here. So this is alpha plus beta. I will write it in the next slide. Here alpha plus beta plus gamma. Okay, what about the first column? Alpha, beta minus alpha, gamma minus alpha. Okay, second column is alpha square, beta square minus alpha square, gamma square minus alpha square. Here 1 0 0. Okay, now apply the formula alpha plus beta plus gamma. This is alpha, beta minus alpha, gamma minus alpha. Here alpha square, this is beta minus alpha, beta plus alpha. And this is gamma minus alpha, gamma plus alpha. Okay, here this is 1 0 0. Right, so therefore this is alpha plus beta plus gamma. And look at that, here also beta minus alpha there, here also beta minus alpha. You can consider 0 into beta minus alpha, take it beta minus alpha commonly. Here gamma minus alpha, here also consider gamma minus alpha into 0 and take it as gamma minus alpha commonly. Okay, and write the remaining here alpha 1 1. Beta minus alpha already taken outside, gamma minus alpha taken outside. This is alpha square, beta minus alpha taken outside, this is beta plus alpha. Here gamma plus alpha, here 1 0 0. Okay, so therefore this is alpha plus beta plus gamma. This is beta minus alpha, gamma minus alpha. Okay, expand the determinant using the third column. What about the third column? This is plus, minus, plus. So since this is 0, leave it. This is 0, leave it. You find out only this term. Okay, 1 into this gamma plus alpha minus of this beta plus alpha. Okay, so therefore what is the answer? This is alpha plus beta plus gamma. This is beta minus alpha. This is gamma minus alpha. And here your alpha alpha cancelled. You will get gamma minus beta. But look at the answer. What is the answer? We are going to prove that beta minus gamma, gamma minus alpha, alpha minus beta is there. Here beta minus alpha is there. Okay, you can interchange. That means taking minus outside. If you take minus outside, here minus of alpha minus beta. Okay, so this is beta minus gamma, but the gamma minus beta is there. We are going to prove that beta minus gamma, but we are getting the answer is gamma minus beta. Again, you can interchange. That means taking minus outside from these two terms. If you take minus outside, you will get beta minus gamma. Okay, again we will get one minus. When you interchange these two, that means taking minus from here and minus from here, I will get plus. This is alpha minus beta, this is beta minus gamma, this is gamma minus alpha into alpha plus beta plus gamma. Look at that, this is your answer. Your right answer is this is. Okay, so therefore this is your RHS. Yeah, please take that. Okay, come to the next problem. The question number 12. Look at that, this is also prove that question. Prove that x, y is that x square, y square, z square. One plus px cube, one plus qy cube, one plus, I'm sorry, not q, only p. 1 plus py cube, 1 plus pz cube equal to 1 plus pxyz, x minus y minus z. I hope this problem not completed in previous classes. If this problem already completed means please send a message chat. You will skip this problem and go to the next problem because this is an important problem. Okay, now come to the LHS. My LHS is, look at that, this term, the third column. Look at my third column. My third column is, okay, my third column having sum of two terms. I have the fifth property. What is the fifth property? If any one row or any one column is the sum of two terms means we can write the determinant value is sum of two determinants. That means split into two determinants. Okay, so I'm going to split the into two determinants. Okay, so therefore this is x, y, z. This is x square, y square, z square. This is 1, 1, 1. Plus this is x, y, z. This is x square, y square, z square. This is px cube, py cube, pz cube. Okay, so look at that. These two terms, I'm writing that this is 1, 1, 1 in the first determinant. This px cube, py cube, pz cube in the second determinant. Okay, this is I'm applying that property number 5. Any one row or any one column represented as sum of two terms means we can represent as sum of determinants. So now look at that. Here I'm taking the first determinant as it is, x square, y square, z square. This is 1, 1, 1 plus. Here, look at that. In first row, I have x is common. Second row, I have y is common. Third row, I have z is common. Take it outside. X, Y, Z in the first row, second row, third row, respectively. And look at that. In this column, P is also common. Take it outside my P also. What are the remaining? So here, I have taken X outside. Therefore, 1 X. Here, X square. P already taken outside. Here, 1 Y. Y square. P already taken outside, Y already taken outside. So here 1 Z, Z square. Okay, so now look at that. These two determinants are look like same. This determinant and this determinant, these two determinants are look like same. Okay, so look like same means but here my first column is X, Y, Z. Here my first column is 1, 1, 1. But here my second column is x square, y square, z square. Here my third column is x square. That means that columns are interchanged, shuffled. I'm going to rearrange the columns of the any one of the determinant. I'm going to concentrate this first determinant. I'm going to rearrange the columns. Rearrange the columns means I'm going to interchange the columns. Okay, so suppose I'm interchanging the columns. Look at that here 1, 1, 1 in the first column. Here 1, 1, 1 in the third column. I'm going to interchange this first and third column. Interchanging column 1 and column 3 elements. So what about the interchanging 1, 1, 1? This is the first column. And what is my third column? My third column is x, y, z. What about my second column? My second column is as it is x square, y square, z square. Okay, plus this is p into x, y, z. Right. When you interchange any two columns or any two rows, the value of the determinant sign changes. That is a second property. Use that second property. Please note that I'm applying the second property. I'm interchanging two columns. When you interchange any two columns or any two rows, the value of the determinant sign changes. This determinant totally it is in plus. So now it become minus. Why? The value of the column C1 and C3 are interchanging. So there is no change in that second determinant 1, 1, 1. This is x, y, z. This is my x square, y square, z square. Okay, so now come to that. Again, look at that. My first column is okay. In these two determinants, my first column is 1, 1, 1, 1, 1, 1. It is okay. But what about second column? Look at the second column, x square, y square, z square there. But here it is not x square, y square, z square. Here it is x, y, z. That means I'm going to interchange these two columns also. Interchanging C2 and C3. I'm going to interchange in first determinant only, not in the second determinant. I'm interchanging C2 and C3. My C1 is first column is 1, 1, 1. Second column is x, y, z. I'm interchanging. My third column is x square, y square, z square. I'm interchanging. Okay, into p, x, y, z. Into the second determinant, take it as it is. 1, 1, 1, x, y, z, x square, y square, z square. X square, y square, z square. Okay, so now look at that. So I have already told that if you interchange any two columns, you will get the value of the determinant, the sign changes. Similarly here also, if you interchange these two, already one minus is there, this minus. Again I'm interchanging C2 and C3, I will get another minus. Therefore minus into minus will become plus. So I am interchanging two columns, I am getting minus. Again I am interchanging another two columns, I am getting another minus. So therefore minus into minus it will become plus. Now look at that these two determinants, both are same. Take it commonly. So then what happen? So when you take the determinant commonly, this is 1 plus p x y z. This is, suppose I am taking the determinant is commonly, this is 1, 1, 1, this is x, y, z, this is x square, y square, z square. Okay, so I'm taking determinant commonly, I'm getting here it is 1, here it is p, x, y, z, right? Now find the value. This is part of the answer. Look at that. This 1 plus p, x, y, z is the part of the answer of the right hand side. This answer we got it. Here still, if you simplify this determinant, you will get these answers, these factors. Okay, so how to simplify this 1, 1, 1? I have already told that if you are getting any one column or any one row is 1, 1, 1, it is easy to simplify. Make it as 1, 0, 0 and find the value of the determinant, you will get the answer. Okay, so therefore this is 1 plus p, x, y, z. This is 1 x, x square. Apply R2 minus R1, 0. Apply R2 minus R1, y minus x. Apply R2 minus R1, y square minus x square. R3 minus R1, 0. R3 minus R1, z minus x. R3 minus R1, z square minus x square. What am I applying? I am applying R2 as R2 minus R1. I am applying R3 minus R1. Why I am applying? I'm going to make it as 1, 0, 0, right? So now you can expand the determinant, but before expand the determinant, look at that y square minus x square there. Here is z square minus x square. Y square minus x square, z square minus x square means you just apply that a square minus b square formula. What is a square minus b square formula? That is a plus b, a minus b. Here y plus x, y minus x. The second term is z plus x, z minus x. Apply that formula and take y minus x commonly from the second row. Take z minus x from the third row and then simplify. Okay. Okay, so this is 1 plus p x y z. Determinant of 1 x x square. Here 0 y minus x. Here apply the formula a minus b, a plus b, y minus x, y plus x. Here 0, this is z minus x, z minus x, z plus x. Okay, so therefore this is 1 plus p x y z. Look at that, here y minus x, here also y minus x. Here also you consider 0 into y minus x. You take it as y minus x commonly from the second row. Z minus x commonly from the third row. Okay, what is the remaining? Here 1, 0, 0. Here x, 1, 1. Here x square, y plus x, z plus x. Okay. Now simplify that. This is 1 plus p into x, y, z. This is y minus x, z minus x. Find the value of the determinant. The value of the determinant is 1 into z plus x minus y plus x. Okay, so therefore this is 1 plus p x y z, y minus x, z minus x. Okay, here look at that. Your x plus x minus x get cancelled. You will get z minus y. So this is your answer. But look at that. Compare with the answer. Comparing with your answer. So here 1 plus p x y z, x minus y. We need x minus y, but we are getting y minus x interchange. That means taking minus outside. When you're taking minus outside, this is 1 plus p x y z. When you're interchanging, that means interchanging x and y, then I will get minus. That means taking minus outside. This is x minus y. This is here also you can taking minus outside. You'll get y minus z. Here I am taking minus outside. Here I am taking minus outside. Minus into minus become plus. Here this will become x minus y. This will become y minus z. This is as it is. Z minus x. So therefore, this is your RHS. See the answer? This is your RHS. 1 plus p x y z, x minus y minus z, z minus x. This is the answer. We have to prove that. Look at that question number 15. Question number 15. What is question number 15? Prove that using properties. This is sine alpha, sine beta, sine gamma. This is cos alpha, cos beta, cos gamma. This is cos of alpha plus delta and cos of beta plus delta, cos of gamma plus delta equal to 0. Using properties only, we have to using properties prove this. How to prove that? Come to the LHS. The first column is sine alpha, sine beta, sine gamma. This is cos alpha, cos beta, cos gamma. Look at that. So here, suppose I am adding C1 plus C2 plus C3. What is the answer? Sine alpha plus cos of alpha plus delta. But here sine beta plus cos of beta plus delta. I am getting different answers. Suppose I am adding R1 plus R2 plus R3, sine alpha plus sine beta plus sine gamma. But here cos alpha plus cos beta plus cos gamma. Here some other answer. So therefore, that row operation, column operation is not possible to apply here, because if you apply that C1 plus C2 plus C3 or R1 plus R2 plus R3, so it is not possible to take in commonly any term. Okay, if I am applying R1 plus R2 plus R3 means I will get that R1, all the elements of R1 getting the same and term means we can take it commonly. But here it is not, I am getting different elements and I am applying R1 plus R2 plus R3. Then what to do, sir? I am going to apply that formula cos of x plus y. You have already studied in 11th standard cos of x plus y formula, cos x, cos y minus sin x, sin y. This is you have already studied in 11th standard. I am going to apply the formula for this because alpha plus delta is there. This is not two terms. Don't apply the property number 5. This is not two terms. Don't apply cos alpha plus cos beta like that. This is different. It is only one term. You have to apply only this formula. So this is cos alpha, cos delta minus sin alpha, sin delta. Okay. Similarly for this term, cos beta, cos delta minus sin beta, sin delta. And this is cos gamma, cos delta minus sin gamma, sin delta. Are you okay? Now look at that. This is my C1, this is my C2, this is C1, this is C2, this is C3. Okay, look at that. My C3 having sum of two terms. Okay, my C3, in C3, all the elements, it is in the form of sum of two terms. Now I am going to apply the property number 5. What is property number 5? If the determinant in any one row or any one column of sorry for the inconvenience, some technical problem. Okay. Dear students, are you able to view the screen PCV? It is visible. Kindly reply. This PCV is visible for you. Yeah, okay. Right. Thank you. So now look at that. I'm applying the property 5. I'm going to take it as this is one column and take it as the another one. This is another column. This is sin alpha. Applying the property number 5. Sin beta, sin gamma. This is cos alpha, cos beta, cos gamma. Okay. And here minus sin alpha, sin delta, minus sin beta, sin delta. This is minus sin gamma, sin delta. Okay. Now look at that. In this third column, your cos delta is common. Here, sin delta is common and minus is also common. Take it outside. What happened? If you're taking my cos delta outside, here remaining cos alpha, cos beta, cos gamma, here also cos alpha, cos beta, cos gamma. If any two rows or any two columns are identical, identical means same elements, having same elements, then the value of the determinant is 0. This determinant is 0 after taking this cos delta. 0 into cos delta, that is also 0. Here taking minus sin delta outside, taking minus sin delta outside, okay, you will get sin alpha, sin beta, sin gamma. Here also sin alpha, sin beta, sin gamma. First column and third column are identical. So therefore, the second determinant is, this determinant is also 0. 0 into minus sin delta, that is also 0. Okay. So now please note that in first one, I am taking cos delta. My first column is sin alpha, sin beta, sin gamma. Second column is cos alpha, cos beta, cos gamma. Third column is also cos alpha, cos beta, cos gamma. Okay, in the second one, I am taking minus sin delta outside. In from my third column, here sin alpha, sin beta, sin gamma, cos alpha, cos beta, cos gamma. Okay, here when you take sin alpha, sin delta outside, I will get sin alpha, sin beta, sin gamma. Okay, so here the second column and the third column both are identical. Same. Here my first column and third column both are identical. So if any two rows or any two columns are identical, then the value of the determinant is 0. So therefore cos delta into value of the determinant 0. Here minus sin delta into value of the determinant is 0. So therefore totally it is 0. Okay, the value of the determinant is 0. This is the RHS. See the RHS? My RHS is 0 only. Okay, now look at that. The 19th problem. A is equal to 1 sin theta, 1 sin theta, 1 minus sin theta, 1 sin theta. Okay, minus 1 minus sin theta, 1. Okay, if A is equal to, let A is equal to this, where 0 less than or equal to theta less than or equal to 2 pi, then option determinant of A, you see that question number, determinant of A is 0, B determinant of A is belongs to 2 to infinity, value of the determinant. C determinant of A belongs to 2 comma 4, open interval 2 comma 4. Okay, D is determinant of A belongs to 2 comma 4. First of all, find the value of the determinant by expanding first row, second row, or third row. Find the value of the determinant. Value of the determinant means first apply the formula expanding along R1 or expanding along R2 or expanding along R3. Whichever is easy for you, you follow that. And simplify. What is the answer you are getting? Look at that, check that. Your determinant value is 2 plus 2 sine square theta. Plus check this answer. Are you getting 2? Determinant of A is equal to 2 plus 2 sine square theta. Are you getting this? Check that. Are you getting the answer? Determinant of A? 2 plus 2 sine square theta. This is question number 19. Miscellaneous exercise, question number 19. So now look at that. This is determinant of A, but the options are given like that. Your determinant of A lies between or equal to 0. Okay, how to find out, sir? But we know that my sine theta is always minus 1 to plus 1. Sine theta always lies between minus 1 to plus 1. What about my sine square theta? My sine square theta is always lies between 0 to 1. Okay, my sine square is lies between 0 to 1. But what I need 2 sine square. Multiply by 2 here, it is 0. This is 2 sine square theta less than or equal to 2. I'm just finding 2 sine square. Again, adding 2, both the sides. In all the terms, adding 2, that is 2 plus 2 sine square theta is less than or equal to 2 plus 2. So therefore, 2 less than or equal to, this is nothing but, this 2 plus 2 sine square theta is nothing but your determinant of A. Less than or equal to, this is 4. So therefore, your 2 less than or equal to determinant less than or equal to 4. Your A determinant of A is lies between 2 to 4. Look at that. This is also 2 to 4. This is also 2 to 4. But this is the correct answer. Why? This is including 2, including 4. But this is excluding 2, excluding 4. Okay. But here we are getting including 2, including 4. Less than or equal to 2, less than or equal to 4. So therefore, this is the correct answer. Your determinant of A, okay, belongs to is 2 comma 4. Closed interval 2 comma 4. D option is the correct one. Okay. Try the 18th one. Question number 18. X, Y, Z are non-zero real numbers. The inverse of, what is the inverse of A? Your inverse is equal to X, inverse of this A. A is equal to X0, 0, Y0. Okay. 0, 0, Z. Find the inverse of this matrix. Find the determinant A, find the adjoint of A, find the cofactors. What is the answer you are getting? You will get it. This is the answer. This is 1 by X, 0, 0, 0, 1 by Y, 0, 0, 0, 1 by Z. Are you getting this? Please check that. Check your answer. Have you got this answer? Determinant of A is X, Y, Z. and find the cofactors, write it in the adjoint of a matrix. You will get the answer 1 by x, 1 by y, 1 by z. Okay, right. So please try to complete the remaining problems. If you have any doubt, you please send the message. I have already given my number 98424 This is my number. Send a WhatsApp. If you have any problem in that exercise, means you please send that problem. I will reply or I will work out the problem in our class. Otherwise, we will go to the next chapter tomorrow. Okay. Thank you all. Thank you so much. Thank you. Bye.